Let's start with example 3. Abimael is not here. Ruby. Oops. Ruby, are you here?
Yeah.
All right. You can actually, I'll let you pick. Do you want to do example 3 or 4?
What?
I'll let you pick. Do you want to do example 3 or example 4?
3.
All right. So for the left-hand side, our x's are approaching negative infinity always. So as these x's goes toward negative infinity, what does the y value do?
Go down.
Yeah. So what does that mean, the f of x's approach? In terms of like if they're going down forever, what value should I put here?
Infinity.
Negative infinity, right? Because they're going down. Okay. And then as x approaches positive infinity is always what we have for the right-hand side. So as x's are approaching positive infinity, what does this side do?
Going up.
Yeah. So what should my f of x's approach?
Infinity.
Yeah, good. Perfect. Thank you, Ruby. Okay, and then Henry.
Yeah.
So for the left-hand side on example 4, what is this doing? As x's are approaching negative infinity, what are my y values doing? On this left-hand side.
Going down. So
Yeah.
So negative infinity again.
Perfect. And then on the right-hand side, as x's are approaching positive infinity, what is it doing in the y?
Going to the right. So
Well, that's
positive.
Huh?
Positive infinity again.
Right. So the x's are moving right. So the x's are approaching positive infinity. But what is it doing vertically?
A straight line.
As I'm moving up, it's going up, but then it kind of evens up. And what number does it even off to?
2.
Yeah. So our f of x's are going to approach 2. Not infinity.
Oh, so if it evens off, it will be you will put, instead of infinity, we put the number that it even off on.
Exactly. Yes. If it evens out on something, then you're putting a number instead of it.
Okay.
And it can do that on either the left or the right hand side.
Okay.
All right, good job. All right, so those are examples for end behavior. What questions do you guys have before we move on to even and odd functions? Okay, if there are no questions, we're gonna finish up with even or odd. Okay, I'm gonna flip my page just so that I have some more space. And if you didn't catch all this, if you didn't write all of it down, I'm gonna post it after class. Oh, I need to post y'all's video from yesterday. It got backed up on YouTube. All right, so now we're doing even versus odd functions. Okay. So first we're going to define even functions and then we'll define odd. So a function is even if f of x is equal to f of negative x. Okay, this is the official definition. You could also rewrite this as f of x minus f of negative x is equal to 0. Okay, so whichever one makes you happier, but I feel like the first one is probably the best. Let me get this out of the way. Okay, so that's the formal definition. Okay, what this really means is that, oops, I meant to write this means that, not just that. So this means that The function is symmetric about the y-axis. Okay, so we should be able to flip it across the y-axis, and if it looks the same, it's even. So an example of a function that's even, so this is our x-axis and this is our y-axis. Maybe we have a quadratic function that's centered around the y-axis. This is even, okay, because I can flip it around here and it's the same function either way. But something like this, or maybe a quadratic is shifted over to the first quadrant, is not even. Because if I reflect this across the y-axis, I'm just going to get another function like it over here. And so then you look like you have two functions instead of just this one. Okay, so that's an example of when it's not even. So there are three ways to decide if a function is even or odd. And I'm going to let you guys pick which of the three ways you want to do. So the three ways are by graphing. Okay. You can also look at a table. This is probably the easiest way. I'll star it. Or you can do a proof, which is probably the hardest way. Okay. So these are the three ways we can tell that it's even. Okay, so if it's even, it has to be centered on the y-axis. Okay. And you can just look and see if it flips. So check to see if it reflects. Okay, so I'm going to do an example here that we haven't done yet. So here's our x-axis, here's our y-axis. Maybe you have something like this. My drawing is not perfect. Okay, but say it's perfectly centered on the y-axis here. I can flip this back and forth as many times as I want, and it will be the same. Okay. The table is honestly probably the easiest way. So you can stick your function, put your function in your graphing calculator or Desmos. And look at your table. You also can just put numbers into your function if you want. And you're going to check. So maybe our example for this one will be f of x equals x squared. Okay. I'm going to pick two numbers that have the same magnitude but opposite signs. So maybe 4 and -4. All right. I picked that because that looked like this definition up here. And if you get the same value, then you have an even function. So when I have 4 squared or -4 squared, I should get 16 either way. So if they are the same, then it's even. Okay, and you can do that with any two numbers, but they have to be the same magnitude, opposite sign. Okay, and the proof, our goal, is to show that f of x is equal to f of -x. Okay, but we have to use the function given. So we'll do this with maybe f of x equals x to the 4th. So I'm going to start off with my f of x, and I'm going to write down what it's defined as. I said it was defined as x to the 4th. Now my goal is to get the x's on the inside to be negative. Now, because this is an even power, I can put a negative x inside of that, and it's still going to be the same as this one, okay? Because it's an even power, it just gets rid of that negative every time. But writing it like this means that it's the same as f of negative x. So we've shown that f of x is equal to f of negative x. Okay, so therefore is what these 3 dots means. F of x equals f of negative x, and f of x is even. Okay, so this is hard. If you're up for a challenge, do the proof. The table is the easiest way. The graph is easy to mess up. Okay, so I suggest doing this table, picking two values that are the same magnitude but opposite sign, and checking to see that they get the same result. Okay, what questions do you guys have about those 3 ways? Okay, we're going to go ahead and do odd. All right. So this was even functions up here. And we're going to do odd functions. Okay. So a function is odd when negative f of x is equal to f of negative x. Okay, so kind of like the one from above, but we have a negative in there. Okay, and this one means that the function can be rotated (180 degrees) about the origin and stay the same. Mostly look the same. Okay. So some examples of odd functions are f of x equals x, f of x equals x cubed, and even f of x equals sine x. Okay, so those are just some quick examples. Our tests are going to be similar. We can still look 3 different ways to see if it works. Okay, so I'm going to flip my page. Does anybody need this another minute?
Yes.
Yeah.
Okay, I'm going to wait a minute. Sorry, I am going really fast. I'm trying to get it all in.
Yes, can you pull up a little bit? Okay, I'm going to go ahead and flip it. I will put the scans up later. I'm sorry. Okay, so again, there are the 3 ways
we can check, we can look at the graph, we can look at a table.